Next question is, a uniform rope of length L and mass m1 hangs vertically from a rigid support. Suppose this is the rigid support from which a uniform rope of length L is suspended, and this length has the mass m1. A block of mass m2 is attached. This is the block of mass m2 attached to the free end of the rope. A transverse pulse of lambda 1 is produced at the lower end. This is the lower end. So here a transverse pulse of wavelength lambda 1 is produced. The wavelength of the pulse when it reaches at the top. This is the top, and when it reaches, the wavelength is lambda 2. Then the ratio of lambda 2 by lambda 1 is. We know that velocity of the wave in a stretch string is V equal to root T by mu, where T is the tension in the string and mu is the mass per unit length. Here mu equal to mass per unit length, and it is same for each point of the string. Tension is T1 at lower end. Lower end is, say it is A. And this is equal to the weight of the block attached to it. So tension in the string at this point is T1. This T1 is given the equal to the M2G. Similarly, at upper end, there are the two weights. One is the weight of the string and another is the tension because of this mass M2. So total is T1 plus M1G. M1G is the weight of the string. So T2 will be equal to, this is the tension at upper end, which is say B. It will be equal to T1 plus M1G, and it is equal to M2G plus M1G. We also know that velocity V equal to nu into lambda, that is equal to root T by mu, where nu is the frequency of the wave and lambda is the wavelength. And we know that frequency remains same if wave travels in media. So for first case at lower end, we can write nu into lambda 1, that is equal to root m2g by mu. This is at lower end. Similarly, we can write nu into lambda 2, that is equal to root m1g plus m2g by mu. This is at upper end of the string. Now taking the ratio, that means dividing the equation number 2 by 1, we will have lambda 2 by lambda 1, because frequency nu will get cancelled, and it will be equal to, similarly mu will get also cancelled, and we will have m1g plus m2g divided by m2g, and on simplifying it will give m1 plus m2 into g divided by m2g. This g and g get cancelled. This implies that lambda 2 by lambda 1 will be equal to root of m1 plus m2 by m2. This is the answer. Fourth question is, a string is stretched between the 2 points separated by 75 centimeter. It is observed that the resonant frequencies are 420 Hz and 315 Hz. There are no other resonant frequencies between these two. That means these two frequencies are successive frequencies. The lowest frequency for the string is, we know that lowest frequency is the fundamental frequency. And for a stretch string, fundamental frequency is given by V by 12. This we have already discussed. We know that frequency of the string, if oscillating in the n number of loops, will be equal to n into V by 12. We are given two frequencies. One is 420 Hz and another is 315 Hz. And these frequencies are in succession because there is no other resonant frequency in between them. So suppose this 315 refers the nth number of segments of vibration, then 420 will refer the n plus 1 number of segment of the vibration. Therefore, we can write that Fn is equal to 315 Hz and it will be equal to n into V by 2L, where L is the length of the string and V is the velocity in the wave. Similarly, Fn plus 1, if it is oscillating in n plus 1 number of loops, the frequency is 420 Hz and it will be equal to n plus 1 into V by 2L. This is the equation number 1 and equation number 2. Now subtract equation number 1 from 2. We will have 420 minus 315, that is equal to n plus 1 V by 2L minus n into V by 2L. If we simplify it, this will be 105, and taking the V by 2L common, we will have n plus 1 minus n. This n and n get cancelled, so 105 will be equal to V by 2L, and this is the fundamental frequency, that is F1. So this implies that the lowest frequency for the string is 105 Hz. This is the answer. Next question is, if the tension and the diameter of the sonometer wire, which is a stretch wire, of fundamental frequency n is doubled and density is make half, then its frequency will become. Suppose the tension is the T in the stretch string of sonometer wire, diameter is D of the wire, and fundamental frequency is n as per the given question. And we know that fundamental frequency of a stretch wire is V by 2L, where V is the velocity of wave in the wire and the L is the length of the wire. This will be equal to 1 by 2L and the velocity is given by root T by mu, where mu is the mass per unit length and T is the tension in the string. This mu is mass per unit length. This mass per unit length can be written as m by L, and mass is density into volume by L, and volume for the wire is the volume of cylinder because wire is in cylindrical form. So we can write it as pi r square, where pi r square is the area of cross section of the cylindrical wire into length L divided by L. This L and L get cancelled, so simply it is pi r square. If we write it in terms of diameter, it will be rho into pi into d by 2 whole square, because radius is half of the diameter. So substituting the value here, we will have 1 by 2L root T by, and mu is rho pi d square by 4. This is the equation number 1. Now there are the changes that tension becomes double of the initial tension, diameter become also the double 2d, and density rho dash will become half of the initial. Now the fundamental frequency will be n dash and it will be equal to v dash is the velocity of the wave in the stretch wire in new case divided by 2L, so it is equal to 1 by 2L root T dash by mu dash, or it is equal to 1 by 2L root T dash by rho dash pi d dash square by 4, and substituting the value we will have 1 by 2L root T dash becomes twice of the initial, density becomes rho by 2 pi into, and density becomes double 2d square by 4. This is the equation number 2. Now dividing the equation number 2 by 1, we will have n dash by n. This is equal to 1 by 2L into root 2t by rho by 2 into pi into 2d square by 4 divided by 1 by 2L root T by rho pi D square by 4. This 1 by 12 and 1 by 12 get cancelled, and n dash will become n into square root of 2t by rho by 2 into pi into 2d square by 4 into rho into pi d square by 4 by t. And now simplifying it, t get cancelled. Similarly, rho also get cancelled, pi get cancelled, and here this d square is 4 is also get cancelled and d square is cancelled. Therefore, we will have it is equal to square root of 2 divided by 1 by 2 into this 2 square, that is 4. So this get 2 and 2 is divided by 2, that is 1. So we will have the fundamental frequency in new case will be also the earlier case. So n dash will be equal to n. This is the answer.